Is my screen visible to everyone?
Yes, ma'am.
Yeah, thank you. So introduction to RNN. So there is three types of major techniques in deep learning. What is that? The first one is ANN. The second one is RNN. Third one is 3NN, sorry, CNN, and also there is another one GN. Right? But we are not doing much GN. That is only for genetic things, and CNN for image processing. Right? And RNN, we are using RNN more for the sequential data, sequential problem solving. Okay. Now, let's start. A recurrent neural network is a type of artificial neural network designed to recognize patterns in sequence of data. These networks are used for various tasks such as language modeling, translation, and image caption. Consider a game changer in machine learning. Right, RNN is already there. Now, in RNN, the major algorithm is LSTM. Guys, LSTM means long short term memory. Right? So, what is long short term memory? Okay. I hope you, I think everyone watched Gajni movie. I think you all people already seen like Gajni movie, like Amir Khan one or the Surya one. Gajni. You people seen Gajni or not? I think all of you already seen that movie, that Gajni
Yes,
one or yeah, okay. So in Gajni, the hero Surya or Amir Khan, how is their memory? Can anyone tell how their memory works after the like the fight and all? He used to forget things, right? He used to forget things after 15 minutes. Is that correct? Right? So in RNN also, because it's a sequence data, so the data will come and will like it will go for the sequence one. But when the upcoming things are like it's going for the model training and the previous data, previous information, the RNN used to forget. The problem called the vanishing gradient descent used to forget the previous one. For example, I am telling I am from India, right? So if it's going from I am from India, then it will forget I. So it is having sort of time like that time or sort of length like this length only it will keep in the mind in the AI. Other things it will forget the previous one. So that is the problem in RNN. That is the problem in RNN. Because of that problem, they introduced LSTM, where long and short both memory should be there. What is the like why we are using LSTM? Both long and short term memory will be there. Fine. How LSTM architecture is? So LSTM having some gates. This is LSTM cell structure. These are the layers. These are the point-wise OP, and this is the copy. These are copied. It's going as x1. This is one hidden, and this is the cell. Having two memories. You people are getting my point? Having two memory cells. So it will allow to retain long-term dependency in data. Having one cell and hidden cell. Now here, what are the memory gates? LSTM use memory gates to regulate the flow of the information, enabling it to remember or forget specific details as needed. Like wherever like the information is less, then only it will forget. Otherwise, it is having, I think in memory gates, it is having input gate, output gate, and forget gate. In input gate, it will take the things. Output gate, it will give the result. And the forget one, wherever the information is less or that is weak, learning wise weak, then it will forget the gate. Three gates are there. Fine. And your basic LSTM, how it's having? It's having two. One is the hidden cell, one is cell, where one for long memory and one for short memory. In RNN, we are having only one memory. Now this is clear, guys. What is LSTM and how is it working? Any doubt here from anyone? Okay. Any doubt? Let me. Architecture of LSTM. One is input output gate. The same I already explained you people. Input and output gates. LSTM has input and output gates to manage the flow of information through the cell. So say input, like we are taking the input and output one, it will give the output. And where it's happening, this input output gets, where is that? That is inside the cell. This input output gets, where is it? Inside the cell. Now forget gate. The forget gate remove information that is deemed unnecessary for the model memory. Which feature contribution are less? That data, that information, it will remove by forget gate. So these three gates we are having. Cell state, a crucial component that carries information access time steps contributing to our network ability to retain information. Are having cell steps. We are having hidden state and the cell state where we are, sorry, long term and short term, two states. Now, training on LSTM model. Same, guys, for training LSTM also same data analysis and the data pre-processing. Then hyperparameter tuning with learning rate, batch size, and other parameters for the model performance. Then third one is back propagation. Utilizing back propagation for error calculation and weight adjustment in the network. So after hyperparameter tuning, we'll get some result. If we are not happy with the result, we will do the back propagation. So it will go back and it will come up with more good accuracy. So these are three steps: data pre-processing, hyperparameter tuning, and back propagation. Fine. Now, application of LSTM. Which field we are using more LSTM? Natural language processing, time series prediction, and speech recognition. Guys, you people can choose these projects. We'll share some projects with this technology. You people can choose it, like time series prediction you can do with LSTM, or speech recognition, natural language processing. So LSTM are used in language translator, sentiment analysis, and text generation with NLP. Time series prediction, forecasting stock price, weather patterns, and other time dependent data is facilitated by LSTM. For time series more, we are using LSTM. Speech recognition. LSTM play a central role in developing accurate and efficient speech recognition system. So these are the major three applications of LSTM. Guys, this is clear. Apart from this, do you have anything in your mind which will come up with application of LSTM? Apart from these three. Okay. Advantages of LSTM over traditional RNN. Yeah. So long-term dependencies. Fine. And the second one, memory cell. Third one, reduce forgetfulness. So long-term dependency. What are the advantages? Already we are having RNN for sequence data. Why LSTM is good? So one is long-term dependency, means it can remember and consider for a long data and information. LSTM can capture long-term dependency and mitigate the vanishing gradient problem in traditional RNNs. The second one is memory cell. LSTM cell state in memory cell is not present in RNN. LSTM cell state allows to maintain information and selectively control in retention over time. Reduce forgetfulness. Forget gets empower LSTM to carefully discard irrelevant information, enhancing learning efficiency. This facility is not available in RNN. So because of these three, LSTM is better one. Now, what is the limitation of LSTM? Yeah, this is little complex, but personally I used many application LSTM, guys. LSTM models can be complex and reduce intensive, requiring significant computational power for training and deployment. Second is overfitting. Without proper regularization, LSTM can be prone to overfitting, particularly when dealing with small data set. If your data set is small, then it's better not to use LSTM. Training time. Training LSTM model can be time consuming, especially when handling large scale data set and intricate architectures. It will take time, little complex, and will face overfitting. But if you are having much good data or more volume of data, then we can go with LSTM. There is no issue. Now, conclusion. How it's working with future developments, industry integration, combined models. So now, ongoing research aims to enhance LSTM architecture and its application in diverse fields like many field, HR, operations, finance, then logistic, transportation, medical, any domain it's working. Combined model. Hybrid model that integrate LSTM with other neural network types show promising potential. We can use other network also. I am using in not in previous project we used AR, deep artificial model, the deep AR. It is the top up of LSTM, which is working very good. Industry integration. The integration of LSTM based system into industry like healthcare, finance, automotive, set to revolutionize operational aspects and decision making process with LSTM. So these are quite aspects of LSTM where we will leverage more. So already yesterday we discussed about RNN, like the sequence data, the functions, the activation functions. Hmm. Now, guys, I have some questions for you people. Let me share this PPT to you people. Then we'll have some question answer discussion. Then we'll go with the practical. No need to worry. Let me share you people first this template. Guys, any doubt in LSTM? Please feel free to ask me. What about? Okay, let me download it first. Let me download it, guys. I'm sending you people. Okay. Okay, one second. Okay, let me share you people. Yeah, please check, guys. I shared RNN. Guys, please open it. Yeah, these two documents done, guys. Deep learning and RNN. Please go through it. Did you people find? Please check your WhatsApp group. I shared the few documents regarding deep learning, ANN, and RNN. Let's do. Fine. Please, all of you, open that. I'm giving 2 minutes. Now it's 8:28. I'm giving 2 minutes. All of you, please open that and have a look. Then we'll discuss some question answers. Take 2 minutes. I hope you all people. Okay, no. Let's go to little question answer section. Okay. Fine. Let me share my Excel. Okay. Let me share the screen. Guys, I need the answers and this session also recording. Who is giving good answers, they will get good marks. After that, please, no one tell me like my movie didn't got good mark. Okay. Let's go to the first question. What is deep learning? Who is going to give answer what is deep learning? Guys, quickly, be fast.
Deep learning is the subset of machine learning.
Deep learning, the subset of machine learning. That is correct. After that,
It's based on neural networks.
Ma'am, it is a method of AI which enables the AI to process the data in a way that is inspired by the human brain.
that is correct, human being. But with what?
Neural network.
With the given data, with neural networks and
Yeah, with so deep learning is the type of machine learning. Sorry, the part of machine learning where they are doing the simulation. They are learning with the help of artificial neurons. Right? They are learning like a human brain. Fine. Okay, I'm done. Ganesh. Fine. Okay, fine. Okay, fine. And my second question is, okay. My second question is, what is activation function? And some examples. What is activation function? And some example. Example means.
the
It
activation
compares the
function
input
decides whether a
value to a
neuron
threshold value.
Function.
I'm sorry, guys. Yeah. Yeah. Okay. So what is activation function? Now. Right.
Activation
Yeah, tell me now.
functions are used to activate the neurons.
It will.
it allows it decides whether a neuron will be activated or not, depending upon the data is important to the AI or not.
Okay. Yes. It will check the like artificial neurons are active or not. So if that is not active, it will give the like power to activate. Okay. So examples.
Softmax, TANH,
Sigmoid function.
sigmoid.
ReLU.
Okay. Fine. Okay. Fine. So when ReLU, we are using when ReLU activation function. When we are using guys ReLU activation function.
Vanishing rate.
And sigmoid, when we are using sigmoid?
In logistic regression also.
Yeah, logistic is there, but like here in deep learning, when we are using sigmoid, okay, it's fine, no worries. Go through it, guys.
Binary classification.
Yes. Okay. So my next third question is here. Which metrics we are using for the performance testing? Metrics using for performance testing in deep learning. Which metric? Performance
Test coverage
testing.
matrix. Load testing matrix.
Sorry, which one?
Load testing and test coverage. Performance metric matrix.
Yeah, that is fine. But which one is the major one? We are testing, okay, this is my thing, this is my thing.
Ma'am, confusion.
Confusion matrix, ma'am.
Yes.
Yes. Confusion matrix. And also, guys, accuracy is there. Accuracy is the major one. Fine. Confusion matrix, that is fine. Classification report, that is fine. Accuracy is the major one. Right? Okay, Sneha, Avneet, Kanish. Okay, now I should go to the answer. So now let me know what is in confusion matrix. What are the things present in confusion matrix? Or what
Summary
is
that
So,
confusion
like,
matrix?
Summary that displays
positivity
true,
and
positive,
negative
false,
values, like
negative
true
values.
positive,
True,
negative,
false,
true, positive,
predictions. false,
negative, false, positive.
Yeah, that is fine. Okay. And other things like accuracy, then precision, then other two things.
F1 score recall.
F1 score recall. Okay, fine. So what is precision? Accuracy, we know what are the total positive from the total one, like total correct from the total experiment. That is accuracy. What is
Like
precision, guys?
how correctly the output is guessed by the model is precision.
Correctly, like positive from the total positive. My fourth one is what optimizer we are using in deep learning. What optimizer? You people can tell any one or two name. What optimizer? When we are doing the model,
RMS prop, Adagrad.
We use SGDs, stochastic gradient.
Gradient descent.
guys, optimizer, the major optimizer. Rather than the correct one only, there is another name. You people heard about Adam?
SGD.
Uh, okay. And guys, the easy one. What is epochs?
Fox is one complete trainings. Breathtaking.
Complete
All the training data is used
Training
at once.
cycle.
Yeah. All the training data. Who give the answer? All the training data goes at
Me.
once.
Me, ma'am.
Ratha,
Tiptoshi.
Yuvraj. Okay. So guys, epochs means all total
Total data is given.
training data will run once and will give you the accuracy rate. Okay. Yeah. Ratha and okay. So the next one is here. Give me proper answer. What is the difference between ANN and RNN? Give me the proper explanation, like not in one line. What is the difference between ANN and RNN?
RNN
in-
has previous memory, ma'am. Like it uses previous memory to predict the next one, ma'am. While ANN does not have that feature. It directly predicts.
Whatever we have data, not previously. RNN deals with the sequential data, which can
Sequential data. It uses
carry
previous
the
data, ma'am.
previous informations. Okay. And where ANN there is nothing criteria, is simple data. It will say. So now the next one.
RNN uses time series, ma'am.
Yeah, that's it. RNN can be many things here. Time series is one type of use case. Okay. Fine. Any other answer, guys?
RNN,
other-
like, it memorizes the previous input values, whereas ANN does not.
Yeah, the same only Sneha. What Yuvraj told us here. Okay. No issue. So we are in ANN or RNN. Okay. And we are dealing with the continuous data. We are dealing with the continuous data. So now, what metrics we will use for validation or the performance testing or the validation? What metrics? Like how we are taking for classification accuracy?
Correlation matrix.
Correlation metrics. And other? Anything else? This is quite same in machine learning, guys. If you are having continuous data, continuous output,
Covariance
output.
matrix, ma'am.
RMSE, MSE, we cannot take. Who told covariance matrix?
Surya, ma'am. Me.
Surya. Okay. What is covariance matrix? Anything you are aware of covariance matrix?
It summarizes the covariance relationships, ma'am, between so many variables.
Yeah, two or more continuous variables. So, okay. Right. So the next one is about LST. So, what are the gates present in LSTM? How many gates?
Input and output
Three
gates,
gates.
forget gate,
Input,
cell.
output.
So, what is the work of these three gates? Explain the work of three gates.
Input and output gate, it manages the flow of information. Forget gate, it removes the information which is unnecessary.
Yeah, that is dictionary words. Now make it simple.
Forget gate decides what to forget simply, and input gate decides what to store in the new cell, and output gate is like controlling the information.
Okay. Any more answers? Correct one. Only I'm not telling Ganesh or Surya. They didn't done correct one. Both are correct only. But we can go with simpler. What we are understanding. Okay. No issue.
They basically decide whether we should send the information, we should pass the information through them or not.
Classifies the
But what they are doing and how many gates are there? Two gates. No issue. Now, how many cells are there in LSTM? How many cells are there? How many cells are there? Guys, we have 174 people. Why only this 5-7 people are giving answers? You people also need to participate.
I'm 6 cells.
6 cells. Which the name of the cells? Okay, okay, fine. Okay. And what are the states? So, what are the states are there in LSTM? What are the states? What are the states are there?
Cell state and hidden state.
Yes. Who gave the answer? I missed it. Yuvraj? Who? Who gave the answer, guys? Answer.
Ma'am, me, ma'am, Surya.
Okay, Surya. Got it. So now tell me one thing. What are the challenges in LSTM? What are the challenges in LSTM?
more complexity.
Complexity, work, fitting, and training time is more.
Yes.
Oh, okay. So it is more complex. The reason behind it, any answer?
Like maybe
Long
Because it
distance.
has lot of gates
It
and
requires
cells.
more power, computational power.
It requires more computational power.
yes.
It is complex. See, you people don't want them complexity. So what are the major region behind complexity? Sneha, you are telling something, Sneha, I think. Sneha, you are telling something, please tell. What's your answer? I thought. Correct. You are mute. You are in mute, Sneha. Okay. Any other answer? Has Sneha? Yeah, tell me.
Like we have
Requires
lot
more
of gates,
resources.
3 gates in LSTM. So it is very complex to send high data through it.
Yeah, you told something.
It requires a lot of resources like high computational power,
Yeah, high
deployment.
computational
Requires
for
more.
what? What are the main reason behind? Like why it will take high computational time? For what?
For
Like
training
It is highly
deployment,
dependent.
cost, training.
Okay, training. Why?
Data which we
Why?
first send can disappear.
Sorry, Prata.
Like the
What
data
you
which we have
telling?
first given can vanish.
Guys, because of the hidden layers, guys, you will have thousands of layers inside. The feature extraction, the model building, everything is happening inside the hidden layers. and it is having many epochs, many time it's running. Because of that thing, the computational is high and this is complexity. Okay. Now what is this goes to you 4 people, for 5 people. Okay. Fine. I will store this report. No need to worry. Okay, fine. No worries, guys. Fine. So now I hope you people got little bit idea, and I'm really happy you people are participating and giving answers. But yes, the major step is like you people having more people, but still less people are on this. Okay, fine. So, okay. So Kanish, you are from which semester?
Fourth semester, ma'am. Second year.
For second year. Okay, good, good. And Abneet, Yubras, you people are
Ma'am, fourth semester.
Third
Second.
year, ma'am. Sixth semester.
fourth only.
Third year.
Okay, third year. Okay, Prata and Surya,
Second year, ma'am. Fourth sem.
Fourth
second
sem,
year
ma'am.
only. And Sneha,
Third year, ma'am.
okay, okay, got it. What about fourth year people? No worries. Guys who are not able to understand, please go through the recording, but better will participate in the live classes only because you will learn many things. Okay. Okay, fine. No worries. Then go and do some time series stuffs. Time series means LSTM one. Let's do a use case. Okay, let's run this. Right. Okay. This is my data. I will share it to you people. I am having the date, I am having the cell. So this is my univariate analysis. I am having only one variable with date. This is called univariate. If I'm having 2, 3, then multivariate, bivariate. The head and this is the tail. This is the plot. This is my sales data. I will explain you people one by one. No need to worry. I'm sharing this code file with you people. First, you need to do from your system as well. Okay. Let me share you this. RNN-LSD. Please go through it. I shared over the WhatsApp. Please download it, the link. So guys, let's start with the time series forecasting with LSTM. Okay. All of you opened? All of you opened the file or not? Okay. Fine. So let me explain first. First one is NumPy and the second one is Pandas. Fine. Third one is Matplotlib and Seaborn. And this already you people aware of it. Fine. Now let's go with TensorFlow. Can anyone having idea what is TensorFlow? Anyone having idea what is TensorFlow?
For setting neural networks.
Hello? Yes, so what? Hello? Call से छात्र. Nowadays I'm getting wrong numbers also. Okay. Yeah, TensorFlow is a framework, guys, where we can do end-to-end development, deep learning algorithms, like how we used to get scikit-learn, the libraries for machine learning algorithm, how we used to get from scikit-learn. The same here, we will get the deep learning algorithms from TensorFlow. Is this clear?
Yes, ma'am.
Okay. Now, from sklearn, we are taking the pre-processing, which is doing min max scalar. Anyone having any idea with min max scalar, guys? What is min max scalar? See, there is a option standard scalar. We already know that. Min max scalar. So min max scalar, what it is doing, it is transform feature by scaling each feature to a given range. Like minimum 5 to 10. Everything will go to 5 to 10 only. Minimum 0 to 1. Everything will minimum 0 to 1, maximum 1. 0, 1. So like that way it will be transferred. Then TensorFlow and Keras. TensorFlow is the top up of Keras. TensorFlow Keras dot preprocessing dot sequence import time series generator. What we are doing here, importing time series generator. And from Keras model, we are taking sequential and dense and LSTM. And we are doing the callback. Fine. Early stopping. What it is meaning, early stopping in TensorFlow means early stopping a regularization technique. In interview, they will ask you what is the regularization technique you people are using in TensorFlow deep learning. Then it's early stopping. That stop training if, for example, the validation loss reaches a certain threshold. For example, your loss is 0.0009. Then you no need to do again training, again more epochs. No need of that. So early stopping is a regularization technique. Now this is clear, and where it is coming from callback. Okay. Now let's load the data file. And this is the path And this is my cells data where I'm reading the file. What is the path? Directly you can read also this file here, no problems. Parse data true. Then this is the data type, cells data. And how many columns are there? It is only RS scans. Only one column are there, nothing more. RSQL is like retail sales. Like retails, sales, clothing and accessory store. Guys, this is the full form of RS scans. Retail source data, retail stores data. We are going to predict the future, how it will. Like how much it will predict in the future, the data, sales data. Now let's go to the describe, and this is my head, this is my tail, and this is the figure 1. This is the plotting data. Now I have some another question for you guys. For time series forecasting, there is another algorithm in machine learning. What is that? What is that? We also discussed. In machine learning, we discussed that. What is that? Search in Google, not search in Google. It's fine.
Arima.
Yes. Arima, who gave the answer?
Kanishk ma'am.
Tanisha. Arima. Yes, Arima is there. Fine. So Arima is what model? Arima is the stats model. Fine. So how we used their Arima, but so in Arima there is many stuffs are there, like stationarity and non-stationarity. So now tell me guys, what is stationarity and non-stationarity difference?
If the mean and variance of the data is continuously changing and not constant.
Okay, Prapta, right? So mean
Yes.
and variance. Okay. In general, normal term, for understandable term,
Over a period of time, it is not in constant, like it is continuously changing.
yeah. So
No proper variance.
there is trend, there is seasonality. That
Yes.
is means data is non-stationary. Okay?
Nonsense.
And if there is no seasonality, no trends, then that is stationary.
Yes, no,
Fine. Okay. So what methods like we can use for convert the stationary into non-stationary? Any idea, guys? I know this is quite tough, but any idea? Like differencing, transforming. Okay, okay. No worries. But there we need to check stationarity, non-stationarity, need to convert it. But here there is nothing scenario. This is very simple. The length of cells data, we are having 334 data. So in cell length of cells data, we are doing minus of 18, 1.5. We are minus of 18. For what we are keeping? We are keeping 18 rows for testing. Fine. 18 rows for testing. Test index. Rest for example, after cutting 18, what are the data are in training and this is the testing. Guys, this line is clear. Fine. Now go to the training dot head. Yes. Training dot tail. Test dot head. Test dot tail. Now help min max scalar. So for scaling equals to what we are taking? Min max scalar. Now we need to feed the training data on the scaling. Now we need to scale train data and test data both. And scaled train data, let's go for the last 5 one. And this is my train data. This is my test data. Now let's help time series generator. See, we have here. Okay. Just tell them. I'm getting bored of this. Fine. Okay. So this time series generator. So what it is doing? It's generating the time series scaled train, scale like how guys we used to do with logistic regression decision tree. This is same, nothing else. Only we need to give your base size for one, length equals to length. Then it's starting from the zero index, and this is my x, this is my y. And this is length of x. And this is my n feature equals to 1. The model sequential obviously using RNN means sequential should be there, not RNN also, because it is having sequential and bagging having parallel. Now LSTM 100 activation function ReLU input same length and feature. And feature means 1. Now we can add more dense and we can do compile. Optimizer equals to we are giving Adam and loss equals to we are giving MSC. Because this is we are going to predict the cells. Cells is the continuous data, so we are giving loss MSC. Now this is my model summary. What we are giving 101 for dense and for LSTM. Now early stopping for regularization. We are giving monitor validation loss, basis equals 2. And again, I'm coming validation generator. The same scaled test state generator we will use test. In the upper one, we used to train. Now we'll do the model fitting generator and epochs. We are giving you 20 epochs and same validation generator equals to validation data, then callback equals to early start. This one, which will show as validation loss. Now let's go what it is coming in 20 epochs. So guys, you people try with little more epochs. Here we are tying with 20. Please do the same and try with more epochs and share me the screenshot. Share me the screenshot. For 20, it's giving bed size equals to 1. Only stop. Okay. Guys, anyone having any idea why it stopped in 4? Because we are giving early stop. Early stop is a regularization. Certain of the things, see here, the loss is very less. So it stopped. Fine. Can you people try with? Let's try with then. Please guys try with different. Let's see. Yeah, now it's went for 5 epochs. Now the result is little better. The validation score is 0.0023. Okay. So guys, can you people do little bit here and there, and can you share me the screenshot? How about you people answer? I wanted to see. Please start doing practical. Change the epochs and share me the result. Please share the results. Yeah. 170. It's going only 5. Loss function 0012. It is quite validation plus 3.5. Not quite more. 3.580. Your validation loss is 3.5. It is quite going for 2-hour fitting and all. It should be. See, your normal loss is 0.0016. Validation loss is quite identified, but here is 0.3. This is problem with the model. Go with less epochs, Rata. Where is validation loss? Share proper screenshot, Yuvraj. Jyotish. Yeah, this is good, Jyotish. 350 bucks you get. This is the good one. 50 epochs. The loss in this is justified. Rafa again. 75. This is also justified. But now this is fine. What about others? Neha, Kanish, Abneet. What about you people? Please run and share the screenshot. Guys, Kanish, Abneet, Yuvras, where are you people? Quick and fast. No responses from anyone. You people are running the code or not? Sneha, Sasi. Guys, please start doing practical. Yeah, Ibras is there. 0 point, this one good one, Ibras. But where is epoch 54? Okay. Okay. Any other answer, guys? Only we have CNN. Rest it's done. Then we'll go with this is Kamath. Okay, Kamath loss is 0.17. Why? 10 epochs. 0.0175, it's quite more Kamath. 0.0175 mutations. Try with more epochs. Please do. Only today we'll have ANN and RNN. Rest other CNN will have tomorrow. And then Monday we'll have NLP. NLP Monday and Tuesday we'll have 2 days NLP. Then you will start internship project. No, I will give one doubt clear class as well. No need to worry. This is Yubras again. Abneet. Good one, Abneet. 16 is good one. 0.11, 0.13. Then this is 0.1. I'm doubt. This is good 170. 0.016. Okay. No worries, guys. So appreciate many people tried. Let's go and learn little more. Okay. So let's go and create the losses in a data frame. And let's plot the loss in normal loss and validation loss. Please plot it. Share the screenshot. Plot it the normal. See, guys, one thing. You changed your epochs, right? Whatever you are getting your result, with that result only do your graph, not my result. So the validation loss is coming down again, it's going up. Here it's down and down. The loss is good one, validation loss is not good here. The model is not better here. Now what we are doing, we are creating a empty list for test prediction. Now first evaluation batch equals to scaled train minus length current batch. Then we are putting in a loop. Get prediction 1 times first prediction, because the index is 0, so this will come up with first prediction. Then we will store all the test prediction. Update batch we are doing because we are going with batch 1, and here we are creating the batch. Now tune prediction, we did fine tuning, so tune prediction we are doing scalar dot inverse transformation on the test prediction. Now let's create another test prediction column, and now let's go with test. So guys, now this is the comparison you can see. So this date actually sales happened 23,764, but our prediction is telling 22,537. So our model is not that much great. But here see 2100, 583, 21,343. This type it's quite okay, but the upper one it's not quite okay. If you change your epochs, and here it is showing 23,764 and here it is showing 23,700 also, this is quite good prediction. Fine. So like this you people can compare the predictions. Now let's do the plot here. So see, actually many places the answer is correct one, but here in some places the answer is not quite matching because we are not getting good accuracy. So what we are doing, again we are doing min scalar, and we are fitting we are doing the full scalar fit transformation on the sales data. Then we are keeping the length 12. Again we are going and rerunning the model with epochs 8. Yeah. Let's get the answer with epochs 8. Okay. Now what we are getting, the loss function 0.0014. Let's go the down. Again we will go and forecast the same thing we'll do again. Now we are putting a range like 2019 11th month, and we are giving periods and frequency equals to months. Month, okay. What we are doing, we are forecasting the upcoming month, what will be the forecast result. Means what will be the sales. Now it will give the forecast result. For upcoming month, it started from 2019 11 month. It will be your forecasted. It is giving by machine. It took training your data, and it is giving forecasted result that this much sales will happen on this dates. The stock price, everything will be same. This is the forecasted one. See, now here, this the blue one are the what we are having the data, and the orange one what machine is telling, it is giving like this way it will work, the forecast result. In stock price and weather prediction, everywhere this is the same. Now you people got little clear like how it's working the time series. So this is my answer. This is the machine prediction. We train the model with this many data, and this is giving this answer. Now, for example, you wanted to give certain like I need this many months to this many months. So this is the result from this many months to this many months. So like that way you can forecast whatever time to time you wanted to correct. Now guys, this is clear. How you people are feeling? Time series is machine learning, ARIMA and all are easy, or this is easy? Which one is easy? Guys, which one is easy?
All are similar.
Which one? Machine learning or this one? Okay, guys, let me know if there is any doubt first. Let me know if there is any doubt. Okay, okay, fine. So please, I think you people, many people changed your epochs. Respect to that epoch, how you are getting the graph and how you are getting the result. Can you people share me? I need this, I need 3 steps. One is the first graph, and second one is the predicted with forecasted. See, I will show what I need wanted to see. See, this epochs we already did. First, do the test one plot, sales prediction, then share me the screenshot of the actual and forecasted. Actual and forecasted. Mm. Share me the sales and prediction. So we'll find out. I will see like how it's coming and who coming is better. Then the last plot. Share me the last plot. This one or this one, anyone fine. I need 3 plots. The 2 plot and 1 compare. We have 15 to 20 minutes. It's fine. You people can do it. Okay. Yeah. Guys, please start practicing because this is the major thing only. Yeah. Someone shared something. Okay. Can you share me the result, like at least 5 or 10, like for what we got forecasted, the numbers, Abneet. Abneet, where is the comparison numbers? Tell me that now. Say the numbers. This is the forecast one. Self prediction 23,000, 21,568, 21,919, 23, 23, 20, 21, 25, 34. Any good answer, guys? Here 23. Can we go with 23? Anyone's coming 23? Yuvras and nice Yuvras. What about others? Can you people please send this one? The comparison one. See, here only we will find out, okay, first few samples, we'll take few samples and we'll see, okay, this was like my actual cells and this is prediction one of forecast one. I think some other one shared one. It's 23,765 with 22,493. This is Kanish. Prata, we'll see Prata. 21,7. No, yeah, this is not Prata. The model is, see, everywhere this is very huge difference. You need to fine tune the model Prata. This is only forecast result. Both. Prata, it's like huge difference. Change your epoch for the fine tune. $22 point. Guys, do little more fine tuning. What about Sneha and others? Sneha, Suraj. Guys, please start see. How much you will do practice here, you will get more knowledge. Later you will go with the recordings or later you will learn from some time. Why? This is time we booked for you people placement internship. So better we will utilize this time only. Okay, got it. So yeah, please send others. This is who's doing this. So this is also quite much difference here. It's like more than 1,000. This is quite more difference. Prata again, it's coming. Oh, it is Akhilesh. Achilles also having 1000 different Achilles. Fine tune role model. It's like 20%. Any more try? This is one. 23,000 is 22,000. 21, 580, 20, 21, 21, 23, 22, 20, 20, 21. This is looking like average Prata. But still you can find it. All of you can find it a little bit. What about others? Ganesh, where are you, Ganesh? What about your final plot and the comparison? What is the answer, Ganesh? Here 23. Here is 22. 493. No. Okay. You people can try it better. Fine. But I appreciate all of you, Akhilesh, Prata, Ganesh, everyone. And this one is 2000. It's more than 2000, guys. 23,000 and it's 20,000. How? See, that day the sales, they happened 23,000. And your machine is telling no, 20,000 happened. But it's fine. Now it's Jyotish, right? At least the Jyotish you tried, I'm happy. You people are trying, that is the big deal. It's fine, Prata, you are also trying. Okay, no worries, guys. All of you, I really appreciate you. You all people who participated. It's fine, you people need to be participate like this. Fine. Okay, we have some 10 to 15 minutes. It's fine. So let's go and discuss something about CNN. Fine, I will give a quick recap with introduction to CNN.